Okay, so what the Pythagorean theorem is, this guy named Pythagoras came up with this idea of how to find any of the sides of a right triangle. And what the formula would be is a squared plus b squared equals c squared. Or what it would be is one leg squared, which is it times itself, plus another leg squared would equal the hypotenuse squared, which would be the angled side that you're trying to find. So an example of this would be, say you have, is 8 squared and 6 squared. Alright? So 6 times 6 is 36. And then 8 times 8 is 64. So 36 and 64 combined would be 100, right? So if you square 100, you get 10, which is what the hypotenuse would be. So it's leg squared plus leg squared equals hypotenuse squared. The Pythagorean theorem works in triples, which needs 3 numbers. So any whole 3 numbers which work in the Pythagorean theorem. Some of these numbers would be 3, 4, and 5, 6, 8, and 10, and 5, 12, and 13. The Pythagorean theorem can be used in most triangles. Like, say you have an equilateral triangle, right? And you have this side and the bottom side and this side, right? And you only need to find the altitude of it. So what you do is you take half of the bottom, and then so it would be half of the bottom would be one leg of the Pythagorean theorem, and this side would be the hypotenuse. So, for example, say this is 6, this side is 6, and this bottom is 10, right? For the Pythagorean theorem, the hypotenuse would be 6 squared, and the leg would be 5 squared. So to find the other leg, you do 6 squared minus 5 squared. So 6 times 6 is 36, and 5 times 5 is 25. So it's 36 minus 25. You would get... get 11. Yeah, you get 11. Yes. So that's what this leg would be. So what it would be like? So that's it squared. So together you get the Pythagorean theorem. Another cool thing about the Pythagorean theorem is that you can use it to find any kind of triangle. Obtuse, acute, or right, like I've already said. For an obtuse triangle, you'd a squared plus b squared is lesser than c squared, would make it obtuse. And for an acute, it'd be a squared plus b squared is greater than c squared. That would make it an acute triangle. The sides won't add up. Another cool thing about the Pythagorean theorem is that a while back, the guy who founded Pythagoras, he had his own group of followers, his own religion, and they all believed that numbers was the importance of everything. That's the cool thing about the Pythagorean theorem. Okay, so for now I'm going to talk about proportions. So one thing about proportions is if 3 sides of one triangle are proportional to 3 sides of another triangle, then the triangles are similar. So a good example of this would be this right here. I don't know if you can see that or not, so we'll just zoom in right there. So that'd be proportional, right? So what you have here is you have 4 on this side and 8 over here. Since 8 is double of 4, these 2 sides are proportional, since they're doubled. Then you have 2 and 4 over here, which makes them proportional, and 5 and 10 over here. So these 2 triangles are similar, since all 3 sides are proportional. Another way to find out if a triangle is proportional is if 2 sides of one triangle are proportional to 2 sides of another triangle, and the included angles are congruent, and the triangles are similar. So say you didn't have this side, so 5 and 10 are gone. So you had 2 and 4, and you had 8 and 4. Well, since these 2 sides right here are proportional to these 2 sides, and if you knew these 2 angles were the same, that means that these 2 sides would also have to be similar, which makes it proportional, which is an easy way to find out how the triangle works. Another thing that proportions are able to be used for is for finding surface area and volume of triangles. Say if the ratio of any linear measurement of an angle is m over n, right? To find the area would be m squared over n squared, and to find the volume would be m cubed over n cubed. So a good example of this would be, say you had two triangles, and this side was 5 centimeters, and then the larger triangle would be over here would be 8 centimeters. To find the area for linear, it would be 5 over 8. To find it cubed, you'd have to have it squared, so it'd be 25 over 64. And to find the volume, you have to cube it. So 5 times 5 times 5 is 125. And then 8 times 8 times 8, that's 64 times 8, that's 64 times 8, shit. 8 times 6 is 48, 8 times 4 is 8 times 4 is 32, 512. It'd be 512, showing that would be the volume of it, and you were able to find that out because of proportions. So let's go over a few examples. So, say for, I'll do that one. We'll do this one, okay? So this one, it gives you two sides. It gives you 12, and it'll give you 6 for the linear. So to find the area, you'd have to cube it. So 12 times 12 is 144 over 6 times 6 would be 36. So it would be 144 over 66. And then that would be the area. That is what's amazing about proportions. Okay, so now we're going to talk about area. And since there's so many different kinds of shapes and polygons, there's many different ways to find area. So we'll start off with a circle. The way to find area of a circle would be pi r squared, with pi being 3.14 and on and on. And then the radius is, the r stands for radius of the circle, and then square to square it. So say you're doing, say r is 3. So you square r, which would be 9, then you times 9 times 3.14. So 9 times 3 is 27.14, it's 27 point something. So that's how, so that would be the area squared of the circle. To find the area of a rectangle, you times length times width. So you had a length of 5 and then a width of 4. You do 5 times 4 and you get 20, which would be the area. The area of a triangle that is not a right triangle would be 1/2 base times height. So say the base is 8 and the height is 2. You cut base in half, so you get 4 times 2 is 8. And that would be the surface area. For a parallelogram, the area would be base times height. So you had a base of 3 and a height of 4. 3 times 4 is 12, and that would be the area of a parallelogram. For a trapezoid, it gets kind of complicated. The area is 1/2 the height, and then it's the top base plus the bottom base. So say the top base is 4 and the bottom base is 5. You'd add those together, so you get 9. And then you get 1/2 of height times 9. So let's say the height is 4. So you get half of height, is that'd be 2. 2 times 9 is 18, which would be the area of a trapezoid. To find the surface area of a cylinder, what you'd get is 2 pi r squared plus 2 pi r times the height. So it'd be 2 times 3.14 times the radius of whatever the cylinder is squared, and you'd add it to the 2 pi r of, and then add height in there. For a prism, the surface area will be 2b plus ph, and then the b stands for area of the base, and then the p stands for the perimeter of the base. So you would add those together to get the area. For a cone, to get the surface area, you'd have pi r squared plus pi r l, which would be the length of this side. So if it's a triangle, flat, you do the hypotenuse. For a pyramid, the surface area would be the area of the base plus 1/2 perimeter times, again, the hypotenuse. To find the surface area of the sphere, you'd have 4 pi r squared, since you're going for the whole sphere. To find the area of a part of a circle, say you have a whole circle and you just want a piece of pi of it, you do pi r squared, and then the arc degree divided by 360, and multiply all that. Now for a regular polygon, the area would be 1/2 of the length of, from the center to one of the sides, times p, which would be the perimeter. That's it on area. how to find the cylinder, the area of volume of the cylinder is very simple. So what you would do is pi r squared times height. So pi 3.14 radius, r stands for radius, and you'd square it, and then multiply it by height. That's an easy way to find the volume of a cylinder. Another easy way to find the volume of a prism would be the base times the height, or the area of the base multiplied by height. That's an easy way to find the volume of a prism. To find the volume of a cone, what you do is 1/3 of pi r squared multiplied by height. So what you do pi times r squared multiplied by height, and then only take 1/3 of that and use it to find the volume of a cone. To find the volume of a pyramid, what you do is 1/3 base times height. So you multiply area of the base multiplied by height of the center of the triangle, and then just take 1/3 of that to use in your volume. To find the volume of a sphere, what you do is you do 4 over 3 pi r cubed. So you do pi r cubed to get that answer. And what you do is you do 4 over 3. So it's a full, right? And then you add 1/3 onto it to get the volume of whatever that is. And that's an easy way to find out the volume of polygons and shapes. So what we have here, we're going to talk about geometry in real life application. So what we have here is a remote control that a really poor person would have. And this has very, very many traits that geometry would have. As you see, you have a rectangle here, as you do here, but it's also a prism, which also applies to geometry. You look at the front, you can see all the various buttons, you know. You have circles, you have squares, you have a trapezoid right here, and yet they're also all prisms. So you can also reach into it. So you have a cylinder here, you have a cube here, and then you have various prisms. Another thing that the controller has is its batteries, which is, if you can see here, it's a cylinder. What are you doing here? How long have you been here? What are you doing?
This whole time.
No!
Ow.
Ah!